I'm Braden Barbary, and this is my Physics 2212 Lab 1 about charged tapes. So, the goal of this lab was to discover the amount of charge on a piece of tape and how many electrons make up the charge. This goal was achieved through experimental methods that will be explained in detail later in the video. The charge was found to be able to create a force larger than gravity on a different piece of positively charged tape. The physics principles. The first one is Coulomb's law, which is the force of the electricity equals 1 over 4 pi epsilon naught times the charge of the first object times the charge of the second object over the magnitude of the distance squared times the direction of the distance. And then Newton's third law, which is a force of A on B is equal to the opposite force of B on A. For the experiments. For the experimentation, a piece of tape would be ripped off of another to create a charge. Then it was moved close to other objects to see the reaction. The tape was attracted to a negatively charged pin, showing that the tape had a positive charge. The final experiment was to put the positively charged tape under another positive piece to see the repulsion, which could be used to find the charge of the tape. With this understanding, the charge was found using a glow script code. In this experiment, the two pieces of tape were the system and the table and hands were the surroundings. And this image is of the experiment where the piece of tape was held under another that was suspended up, and you could see the tape begin to float. For the coding, I had the constants, Phys, which is 1 over 4 pi epsilon, and then the charge of a proton, the scale factor, which was just used for arrows, and the constant force of gravity. And then the length of the tape was 0.2 meters, the mass, the distance of when you could start to see the tape float, and then the total atoms, which was an estimate used with the mass of the tape. And the force of gravity, which is negative mass times a grav, the force of electricity, which is the opposite of the gravity, and then the charge is found using the formula, Coulomb's law, and then getting Q by itself, and then printed off the grav forces, and the electron amount, or the electrons lost, was found by the charge divided by the charge of a singular proton. And this slide of coding was just to get the image right and the results and the arrows, and it gave this result, which this is the suspended piece of tape and this is the piece of tape held under it, and this green arrow represents the force of gravity and the orange arrow represents the force of the electricity. And in the end, the gravity was negative 1.96 times 10 to the negative 3 newtons, and I found that a charge on a piece of tape is 1.63 times 10 to the negative 8 coulombs. And the amount of electrons lost was 1.02 times 10 to the 11th. So, the assumptions and potential errors. The charge is assumed to be the same from when it is created to when it is tested, and the charges of both pieces of tape are assumed to be the same. The forces of gravity and electricity are set equal to each other, but this leaves out any other potential forces, and these forces could be due to air resistance or for movements in the air that could create minimal differences. Now what if? What if electrons had a positive charge and protons had a negative charge? The repulsion between the two pieces of tape would still happen because they would still both be of the same charge. But the difference would be that it would now be repelled by the negatively charged pin and any other negative object. Why? Why is it important to handle the charged tape as little as possible? Hands and other objects are able to slowly neutralize the tape upon contact. And, in conclusion, through experimentation and physics laws, a charge was found for the pieces of tape. This charge should be very close to the true charge because the assumptions and potential errors are so minimal.